Hi there, my name is Heather, and today we're going to talk about energy systems and exercise, as well as ATP production and utilization. Alright, so starting off strong with this graphic here. So this is just a really good visual and breakdown of the Krebs cycle and aerobic respiration. Krebs cycle and aerobic respiration, are interconnected processes that break down nutrients to generate ATP. What is ATP? ATP is adenosine triphosphate, and it is the energy currency of cells. Why is this important for exercise physiology? Exercise demands energy. Different systems provide different types of energy based off of the intensity and the duration of the activity that you're performing. Understanding these energy systems is essential for athletes, for athletic trainers, for healthcare providers, for kinesiology majors, for anyone who wants to be involved in physical activity. Understanding these systems helps to optimize performance. So, ATP is used for various cellular processes. So, we'll go back to our chart here. One of these cellular processes is the Krebs cycle. These processes create energy within cells, outside of cells, and help our bodies to function on a day-to-day basis and maintain homeostasis. ATP is continuously regenerated through ADP, or otherwise known as adenosine diphosphate, through these cellular processes. So, let's talk about these different systems. We're going to talk about 3 different energy systems today. One, we're starting off with the ATP PCR system, also known as the phosphagen system. This system is for super speed and high power. This is ideal for short bursts of activity like sprinting or powerlifting, high power short bursts, but it's very limited in its duration. Next, we're going to talk about the glycolic system. This is the anaerobic breakdown of glucose or glycogen that then generates ATP. So this process is best used for moderate to high intensity exercise. So glycolic system, which works without oxygen, lasts longer than the phosphagen system, and it breaks down carbohydrates into glycogen, then into ATP. And it's in this system that powers your moderate to high intensity activities, like a fast-paced game of basketball. Lastly, this is the aerobic system, which uses oxygen to convert carbohydrates into fats. The aerobic system uses oxygen to convert carbohydrates and fats into ATP. This is best for that long distance activity, the marathon runners or cycling, Tour de France. This is that long-term energy source. Let's talk about what fuels these different processes. So our phosphagen system, ATP PCR system, relies on phosphocreatine to create that ATP. And then we already kind of talked about how the glycolic system, it will break down glucose from carbohydrates to then create ATP. And then our aerobic system really is using all of that stored energy for those long distances. So as we change our form of exercise, these systems are going to work differently. So our body shifts reliance on energy systems based on the type of exercise intensity. So at the start of our exercise, we're going to be using that ATP PCR system. And then as that duration of the activity becomes longer, we'll switch to the aerobic type system. So here, let's talk about the production rate. By that I mean how quickly these different systems produce ATP. And this really makes sense after what we just talked about and how these different systems are used. So in that phosphagen system, ATP is produced very quickly, but in small quantities. And that's going to make sense for that type of activity because it's short burst activity. So we need that ATP very quickly, but not for a long duration. And then going down the list here, that glycogen system, anaerobic system, easier to pronounce, generates ATP quickly, but then also accumulates lactate. And then lastly, that aerobic system produces ATP at a medium rate, but in high quantity. All right, so here we're referencing some studies that have really dove into this idea, and have even gotten some numbers here. So this is within the muscle cell. ATP stores can sustain short term, so that PCR system, from 15 seconds, the longest, to 2 seconds at the shortest. So why is this important? Understanding these energy systems is essential to optimize exercise performance. And then we can also tailor training to the specific energy system. So say you're a power lifter, we can add these specific chemicals, phosphocreatine, into your diet so that you can have more of that ATP available. So high performance athletes have a common objective, despite the diverse nature of their sports, to effectively manage their performance and achieve sustained optimal outputs throughout the entirety of their event. We can negate that decline in performance through understanding these systems and then preparing for that specific activity the best way possible. So personalized training can lead to improvised efficiency, endurance, and overall performance for the athletes themselves. This is a great visual that kind of goes through each level as to how that different nutritions can help influence these different systems. Let's kind of just look at this one here. So muscle PCR depletion, if this is happening quite quickly within that first system where we want quick ATP production, then let's get creative in our loading and our increasing the muscle CR and PCR stores. It's very cool. These are the references I use along with Mr. Schubert's lectures, and I did watch the Amoeba Sisters video, which was helpful in explaining this better. Thank you. Please let me know if you have any questions.